Hello everyone, welcome to Dima Tutorials Online School. My name is Victor Onimisi. Today we are going to be looking at JAMB 2018 past questions. Before we start, if you haven't registered for our WhatsApp class yet, it is important to join others who are preparing for the same exam as you and learn with us. The fee is just 1,000 naira for each subject and 2,000 naira for use of English. Like I said earlier, we'll be looking at JAMB 2018 chemistry past question. Now let's dive in. Let's move to question number 8. Question number 8 says that the boiling of fat and aqueous caustic soda is referred to as dash. The boiling of fat and aqueous caustic soda is referred to as dash. Now, let's simply do something here. Now, I need you to understand that first thing first, you will not always know the answer, sadly, to every question you are going to be coming across in any examination, all right? You may not know, you might know 99.9% of the answers, all right, very well, but there will still be that 1% left that you will not know because you are simply human, all right? But then there's a trick you can use, all right? If I come across a question and I do not know what the question is even asking about, all right? If I am a student of that course and I've studied that course very well, now there's a trick you can play, and then there's a trick you can use and you simply get the right answer. Now, look at what I will do. I don't know what this question is talking about now, assuming I don't know what the question is all about. Now, I'll first of all look at all the options and then pick out the wrong options. Then I'll be left with the right answer. That is simply the trick. Look at the options very well, pick out the odd ones, and then you'll be left with the right one. Now, let's look at the option. The first option we have is hydrolysis. Now, what is hydrolysis? Hydrolysis is simply the process or the method of using water molecules to split up a chemical substance. That is what hydrolysis is. It is different from hydration, all right? Hydration is adding the addition of water to a substance, all right? But hydrolysis is the use of water molecules to split up a chemical substance. You are not only adding water molecule, the water molecule is splitting up the chemical substance. Now, a perfect example is in the reverse process of esterification reaction. Now, esterification reaction is a reaction in chemistry which involves the addition of an alkanol, which is formerly known as the alcohol, to an alkanoic acid to yield a class of compound which we call ester or alkanoates and water. Now, this statement is called esterification because so you are producing ester, so esterification. Now, the reverse process now, which involves the addition of ester or an alkanoate to water molecule to give back alkanoic acid and alkanols, which are the parent substance that form that ester, is known as hydrolysis. Now, look at what is happening. In the reverse process, that water molecule is splitting back the ester, the alkanoate, now back into its parent's chemical substance, which is alkanol and alkanoic acid. So the water molecule there is responsible, it splitted it. So that is why we call it hydrolysis. All right, so that is what hydrolysis is. Now, if you look at it now, it is not in respect to what we are talking about. What the question is asking us is the boiling of fat in what? In aqueous caustic soda, with aqueous caustic soda. So, and then hydrolysis is explaining another thing. So hydrolysis is out of it. All right. So now let's look at the next option, which is what? Esterification. Of course, I've explained esterification previously now as what the chemical reaction that involves the addition of alkanoic acid or the reaction between alkanoic acid and an alkanol to yield what? An ester and water. So now, this is not in respect to the question that's given to us. The question is asking us about what? The boiling of fat with aqueous caustic soda, right? Then acidification. Acidification, that's the next option, has to do with what? The production of acid or the addition of acid to a substance, all right? And then that is not the case here. Now we are looking at fat, which is an ester or a salt, and what? And caustic soda, which is a base. So with this is and caustic soda, which is a base. So this is not acidification. Now, if you look at all these options, now I have picked out 3 options to be wrong. So the next option would definitely be the right answer. All right. So this is how to pick out the odd options, and then you are left with the right answer. Now, let me explain what saponification is, which is obviously the correct answer here now. Saponification is the process of preparing soaps, right? It is basically the addition of esters, which can be sometimes fats, oils, and then with caustic soda. All right. So that is what saponification is, and then at the end of the day, you produce your soap base or your soap, and then this soap here now is what we use to prepare every other forms of soap with other additives, right? So that is what saponification is, and that is the correct answer. Now, I know you might be wondering, like, what if I'm not good with the subject? How will I even be able to know all these options before I know which one is wrong and which one is right? Right? That is what this tutorial is all about. That is what DIMA online tutoring school is all about. So make sure that you register, and then we'll be there to put you through in all of the subjects that you'll be doing during your JAMB. Now, having said that, let's proceed to question number 9. Which of the following pairs of substances will react further with oxygen to form a higher oxide? Quite an interesting one. Which of the following pairs of substances will react further with oxygen to form a higher oxide? A will have carbon 4 oxide and water. B will have nitrogen 2 oxide and water. C will have carbon 2 oxide and carbon 4 oxide, and D will have sulfur 4 oxide and nitrogen 2 oxide. Now let's look at all the oxides we have first. We have carbon 4 oxide, we have water, we have nitrogen 2 oxide, we have carbon 2 oxide, and then we have sulfur 4 oxide. Now let's look at them. First of all, let's start with carbon 4 oxide. Now, carbon 4 oxide cannot react with oxygen, right, to form a higher oxide, right? It cannot react with oxygen further to give a higher oxide. Now, what is even an oxide? An oxide is simply a binary compound which consists of only 2 elements, one of which is oxygen. Right? The next element can be anything, but it consists of only 2 elements. Only 2 elements are present, and one of the element is oxygen. That is why it is called an oxide. For example, if I have sodium and oxygen as a compound, I have sodium oxide, Na2O, right? Now, if I have carbon and oxygen, I have what? I have an oxide, carbon 2 oxide or carbon 4 oxide. Any element, just know that an oxide is a compound, a binary compound that contains 2 elements, one of which is oxygen. All right. If you have 2 elements and one is not oxygen, all right, or you don't have oxygen there, then that compound is not an oxide. All right. So now that we know that, let's look at the oxide. So carbon 4 oxide, like I've said, cannot react further. CO2 cannot react further with oxygen to give us a higher oxide. All right. So just know that carbon 4 oxide is out of the option. Then let's look at carbon 2 oxide. I want us to look at all the oxides first before we look at the option and pick out which one is correct. Now, carbon 2 oxide, CO, is formed from insufficient supply of oxygen, right? So now, if more oxygen is added, right, carbon 2 oxide will react with that oxygen to give us what? To give us carbon 4 oxide, and that is the higher oxide. Now, this is practically seen from people that uses the traditional method of cooking from your wood and all of that. You discover that if you are cooking with your wood flakes, now at the far end of the pot and where the wood is, you discover that the gases that is coming out is very, very dangerous, choking. But as it keeps on going up, it's as though it is spreading and all of that, and the effect is not as harmful as it was while it was down. That is because as it keeps on spreading, it keeps on coming in more contact with oxygen, which therefore converts the carbon 2 oxide that is poisonous before into carbon 4 oxide, which now your plants can now take in successfully as they are breathing in gas, and then they will breathe out oxygen back to us, and then we take it and breathe in, and we also breathe out carbon 4 oxide. This is just the interaction between us and the environment and all of that. So carbon 2 oxide in essence will react further with oxygen to form a higher oxide. So carbon 4 oxide is out, carbon 2 oxide is in. Okay, let's look at water, H2O. Although we have a higher oxide, which is called a peroxide, hydrogen peroxide, H2O2. Now, it is not formed by the addition of oxygen to water. Water will not react with oxygen to give us that compound. Alright, so H2O, which is water, is out of this. It will not react further with oxygen to give us a higher oxide. So we've marked out carbon 4 oxide and water. Carbon 2 oxide is part. Now, let's look at I think we have only 2 oxides left in the option, which is nitrogen 2 oxide, NO. Nitrogen 2 oxide will react further with oxygen to give us a higher oxide of what? Nitrogen 4 oxide, NO2. Same thing with sulfur 4 oxide, SO2, will react further with oxygen to give us a higher oxide, which is SO3. So from all the options so far, we've seen that there are only 3 oxides out of all the oxide that's given to us, or out of all the compounds that's given to us, that will react further with oxygen to give us a higher oxide. And those 3 compounds are carbon 2 oxide, nitrogen 2 oxide, and sulfur 6 oxide. So now let's pick the options now and see. The first option we have is carbon 4 oxide and water molecule. And water, these 2 oxides or these 2 compounds are out of it from our explanation so far. So that option is wrong. Then the B is nitrogen 2 oxide and water. Although nitrogen 2 oxide will react further with oxygen to give us nitrogen 4 oxide, the water molecule that is paired with it cannot. And the question is asking us which of the following pairs, meaning they are interested in the both of them being able to react further with what? Oxygen to give us a higher oxide. So in this case, nitrogen 2 oxide can, but water cannot. So that option is not the perfect option. Let's look at the C aspect of it. Here now we'll have carbon 2 oxide and carbon 4 oxide. Same thing as the previous. We'll have carbon 2 oxide can, of course, react further with oxygen to give us a higher oxide, but carbon 4 oxide cannot. So the pair is not perfect. And then we are left with the last option, sulfur 4 oxide and nitrogen 2 oxide. If you look at it now, sulfur 4 oxide will react further with oxygen from our explanation so far to give us sulfur 6 oxide, SO3, and nitrogen 2 oxide, NO, will react further with oxygen to give us what? Nitrogen 4 oxide, NO2. So the both of them can react further with oxygen to give us a higher oxide. So it therefore means that the correct answer here is what? D. Alright, I hope you get that.